Right, another past exam question. So this was a core maths C3 question from January 2008. This was taken from Edexcel and this is question number 6. So let's have a read. So in this case, part A, use a double angle formulae and the identity cos A plus B, and that is cos A cos B minus sin A sin B, to obtain an expression for cos 3x in terms of powers of cos x only. So let's see how this can be done. So let me try part A over here. So let me copy down that identity. So we have cos A plus B, and this is one of the compound angle formula for cos. So cos A plus B, and that is cos A cos B minus sin A sin B. So sin A sin B. So we need to obtain an expression bearing in mind for cos 3x, and we need to write our answer in terms of powers of cos x only. So what I'm going to do is to get an expression for cos 3x. So 3x is the same as a 2x plus x. So 2x plus x is 3x. So in that case, I'm going to take my a to be 2x and my b to be x. And on that basis, let's replace in this identity above. So we're going to have cos a, which is 2x, plus b replaced by x, and that is equal to cos a replaced by 2x multiplied by cos b replaced by x minus the sine a replaced by 2x multiplied by sine and b replaced by x. Now let's go one further stage. So we're going to have cos on the left, 2x plus x is 3x, and that is equal to, so at the moment let me copy the cos 2x cos x minus sine 2x sine x. Now if I pick up my red pen, now we have an identity for cos 2x as well as sine 2x, so we need to apply identities here, especially when the question says write our answer in terms of powers of x, cos x only. So we need to write this in terms of powers of cos x only. Now the first identity that comes to mind is the identity for cos 2x. So that is the double angle of cos. And one of these double angles is in terms of cos. So I'm going to use the version for cos 2x purely in terms of cos, which is 2 cos squared x minus 1. So that is the formula for cos 2x which I'm going to be using. And there is a double angle for sine. So there is certainly a double angle for sine. So I'm sure that you know sine 2x is 2 sine x cos x. So I'm going to apply the double angle of sine as well as this version for the double angle of cos, and apply them to this very equation here. So let me go back to my favorite color blue. So when I apply, I'm going to have cos 3x on the left, as you can see. That is equal to cos 2x, which is 2 cos squared x minus 1. So let's replace. So 2 cos squared x minus 1 multiplied by cos x. So don't forget to multiply by cos x minus. So minus sine 2x. So let's replace by 2 sine x cos x multiplied by the sine x, don't forget from here. So multiply by sine x. Now let's go one stage more. Let's multiply brackets. So 2 cos squared times another cos x is 2 cos cubed x minus 1 times cos x is minus cos x. So I've multiplied this bracket by cos x to give me these terms here. And let's do the same. Let's multiply these two. So 2 sine x times sine x with the minus in front is minus 2 sine squared x, not forgetting the cos x which follows. Okay, so I've multiplied this term by the sine x to give me this very term here. Now, we're still not done because we need to write our answer in terms of powers of cos x, and we have this sine squared x term here. So let's try and get rid of the sine squared x, and there is an identity that will enable us to replace the sine squared x term by a cos squared x term, and that is the fundamental Pythagorean identity. So remember the fundamental Pythagorean identity. Remember the identity that is cos squared x plus sine squared x, and that is equal to 1. So let's rearrange for sine squared. So when I carefully rearrange, sine squared x will then be 1 minus cos squared x. So rearrange accordingly. And let's apply this result to this main step here. So on the left we have cos cubed x, or cos 3x rather, so cos 3x. On the right we've got 2 cos cubed x, so 2 cos cubed x, minus the cos x, so minus the cos x, minus the 2, so minus the 2, sine squared x, let's replace by 1 minus cos squared x into the cos x term from here. Let's go one stage further. So let's tidy up the right hand side. So if I get rid of the brackets firstly, I'll get 2 cos cubed x minus cos x minus 2 times 1, but don't forget this cos x term here. So minus 2 times 1 times cos x is minus 2 cos x, and minus 2 times minus cos squared x times a cos x is plus, so minus times minus is plus 2 cos cubed x. So be careful with your simplification, your multiplication. So I'm going to simplify, so that step's going to follow. So on the right I've got a 2 cos cubed x plus another 2 cos cubed x, that being 4 cos cubed x, and I have a minus cos x minus 2 cos x, that sums to minus 3 cos x. So that should be the solution. That is the solution to part A. We wrote an expression for cos 3x in terms of powers of cos x only, and we did that very thing over here. So that's the solution of part A. Let's move on to part B. So there's 2 parts to part B. So let me continue here. Whoops. Let me be as neat as I can. So B part 1. B part 1. Prove that the left hand term, so cos x over 1 plus sin x plus 1 plus sin x over cos x, and we need to prove that the left hand side is equal to the right hand side, which is 2 sec x. So let me consider the left hand side, and let's simplify this and eventually prove that when we simplify this we get the right 2 sec x. So I'm going to consider the left hand side. So in this case we have, let me copy that down, so we have, let me make it as neat as I can, cos x over 1 plus sin x, so 1 plus sin x, plus a 1 plus sin x. Let's keep these terms in a bracket, divided by the cos x, And as I said earlier, let's simplify this term on the left, and let's prove that when we simplified it to the maximum, we're eventually going to get 2 sec x. So first things first, let me take a common denominator of 1 plus sine x cos x. So if I take a common denominator of this very term, in the numerator we're going to have a cos squared x plus a 1 plus sine x squared. So that is what you'll get when you take a common denominator of this term. Further to that, let's multiply the 1 plus sine x squared. So on top currently we have a cos squared x from here, plus, and if I multiply 1 plus sine x squared, we're going to get 1 plus 2 sine x plus sine squared x. So that is what you get as a result of the multiplication of this particular bracket on top. Let me keep the bottom term as is, so 1 plus sine x cos x. So I'm not going to multiply out the denominator, let's leave that as it is. Now remember the identity, the fundamental Pythagorean identity. So if I take my red pen, so remember the fact that cos squared x plus sine squared x is equal to 1. So the reason why I note that is I'm going to group this cos squared and the sine squared term. So remember, cos squared plus sine squared is equal to 1. So with that being said, if I go back to my favourite colour, so cos squared plus sine squared, let's replace by 1. Plus this one from here, so plus 1. Not forgetting the 2 sine x from here, divided by the term in the denominator. So let me be as neat as I can. So there we go. So divided by the 1 plus sine x into the cos x term below. Let me continue along the line. 1 plus 1 is 2, so it's a 2 plus 2 sine x, all divided by the term in the denominator, 1 plus sine x into cos x. Now from this step I'm going to factorise the numerator. So if I take a common factor of 2 from the numerator, I'm left with 1 plus sine x divided by the term in my denominator, which reads 1 plus sine x into cos x. And as you can see, I can cancel the 1 plus sine x terms to give me 2 over cos x. And remember, the reciprocal of cos is sec, so don't forget this. So sec x is the reciprocal of cos, so 1 over cos x gives us sec x. So bearing in mind that we're going to have a 2, 1 over cos is sec, so 2 sec x. So we did indeed prove that when we simplify the left hand side step by step, applying the relevant formulas, we do indeed get 2 sec x, the term on the right. So that completes B part 1. So part A, B part 1 are complete. Let's have a go at part 2 of B. So hence find for values of x, or for angles x between 2 pi and 0, all solutions of this trigonometric equation. Now bearing in mind the left hand side of this equation is the same as the left hand side of this term, which we've proved to be equal to 2 sec x. So I'm going to use that very term 2 sec x to rewrite this trigonometric equation. So if I follow through, here's part 2. So I'm going to call this equation star, and I'm immediately going to say that we can rewrite, so we can rewrite star as, and let's rewrite it as a result of this solution to part 1 of B as 2 sec x. So I've got a 2 sec x on the left, and that is equal to the 4 on the right hand side of star. Now let's divide both sides by 2 to give me sec x, that is 4 divided by 2, which is 2. And bearing in mind that sec is the reciprocal of cos, so let's follow through. So I'm going to write the left as 1 over cos x is equal to 2, which implies that cos x is half. Now let's solve this trigonometric equation, and let's find the angles x between 2 pi and 0. First things first, what I tend to do is I tend to work in degrees first. So bearing in mind that pi radians is 180 degrees, that would make 2 pi here 360 degrees. And bearing in mind the conversion, 0 is still 0. So first I'm going to find all of the x angles between 360 and 0, and then I'm going to use this conversion to convert to radians later. So let's work in degrees first. Let me pick up my blue pen and let's follow through. Now there's a number of ways to solve basic trigonometric equations. I'm going to be using the cast diagram. First things first, I see a plus half on the right, so I'm going to note that my cos is positive. Okay, so that it gives us an indication where to plot it on our cast diagram. So to work out x from here, x is the inverse cos of half, and that's a standard result. Cos 60 is half. Now since our cos is positive, now if I draw a quick cast diagram, so it's represented by a circle, our cast diagram, and it's divided into 4 quadrants. So let me divide this circle into 4 quadrants. Let me label the quadrants. Now if you're unaware in terms of how we solve trigonometric equations, I have created videos in the past and they are on my channel, and I'll provide links to those videos in the description below. So be sure to check out these videos. These videos are done in a step-by-step format. But let me briefly talk to you about the process. Now in this cast diagram, we label the first quadrant A as sine, cos and tan of any angle between 0 degrees here and 90 degrees here is positive. We label the second quadrant S because between 90 and 180 only sine is positive, cos and tan is negative. We label the third quadrant T because tan of any angle between 180 and 270 is positive. Sine and cos, however, are negative for angles between 180 and 270. And we label the last quadrant C because only cos of angles between 270 and 360 are positive. Sine and tan, however, are negative between angles 270 and 360. So we're dealing with a positive cos, so we need to plot our angle of 60 where cos is positive, which is this first quadrant and this last quadrant. And we measure the angle, so we represent angles from the horizontal. So from the horizontal in the first quadrant, here's roughly 60 degrees. And in the fourth quadrant from the horizontal, so in the fourth quadrant, here's the line which represents 60 degrees in the fourth quadrant. Now, going back to our given range, we need the angles between 0 and 360, so please bear this in mind. So if I go back to the cast diagram, if I pick up a red pen, the first angle is from this 0 degree line, and we measure positive angles, if you're unaware, in the anti-clockwise direction from the 0 degree line, and negative angles from the 0 degree line in the clockwise direction. Now, going back to the range, we're looking for positive angles. So from the 0 degree line in the anti-clockwise direction, the first of the angles should be 60 degrees. So if I pick up my blue pen, I'm going to name my first angle x1. x1 is 60 degrees. Let's work out another one. It is possible to work out another one. So if I take a different coloured pen, maybe this green, our next positive one will be from this 0 degree line until we reach the next line, and that angle is going to be 360, one revolution, minus this acute angle of 60. So it's 360 minus 60, that being 300 degrees. Now, we're unable to calculate more because an additional angle goes beyond this range. So one more would be a 361 revolution plus 60. So 360 plus 60 is 420, and as you can see, it goes beyond our range of 360. Further to that, our angles are in terms of degrees. Let's use this conversion. Let's convert it in terms of pi. So remember the conversion. Let me write it down in a corner. Pi radians is 180 degrees. So that means that 1 of a degree would be pi over 180. So in other words, if I multiply these two by a factor of pi over 180, I can convert them in terms of pi. So I can cancel these two zeros as far as the first solution is concerned. Cancelling the 6 with the 18, it goes 3 times. First solution in terms of pi, pi over 3. I can do some cancellation here. I can cancel the zeros firstly, and let's have a look. So 3, so it goes into 3 goes into 18 6 times, 3 goes into 30 10 times. I can cancel further. 2 goes into 6 3 times, 2 goes into 10 5 times. So the other solution, x2, I can't cancel further. I'll leave it as 5, not forgetting the pi, so 5 pi divided by 3 radians. So here are the two solutions that we have. Pi over 3, 5 pi over 3. These are the solutions to this equation given as far as B part 2 is concerned. So that completes that part, and that also completes the question in its entirety. That sadly ends this video, so I hope you enjoyed this video. If you did enjoy the video, be sure to subscribe for more content like this. I hope to see you again soon. Thank you.